Hello, viewers, and welcome to Queen Amadi Smart Clinic, your online channel for quality STEM education. With your tutor, Sir Principal Queen Amadi Sandy. In today's lesson, we want to look at chemistry, as you are seeing on the board. And the topic is what? Limit in reagent and reactant in excess. It's a topic in chemistry for those preparing for WAS. That is, it is meant for high school students, and also for those who are in universities. Maybe you don't understand the concept. So I think this is an opportunity that you should grab so that you can understand the concept. So limiting reagent and reactant in excess. So I want to define what a limiting reagent is and what a reactant in excess is. Um, for a chemical reaction to occur, we need to have two ends. We have the reactant end, then we have the what? The product end. So the chemicals that will react to form the product is what we call the reactants. And the reactants that are reacting for the product to be formed or for a product to be formed, one of the reactants is going to run out first or is going to finish before. So the reactant that is used up completely in the chemical reaction is what we call the limiting reagent. And the reactant that is left after the limiting reagent is completely used up is what we call the reactant in excess. So I want to make an illustration so that we can better understand the concept. Now let's say we are given to make one sandwich, and in making one sandwich, let's say we are given what, 6 slices of bread and 8 slices of butter, as I've written here. And now to make one sandwich, they said we need two what? 2 slices of bread, 2 slices of bread, and 3 slices of SLI, 3 slices of butter. This is the condition. Now they said in order for us to make one sandwich, we should use what? 2 slices of bread and 3 slices of what? Butter. So we want to now know the bread and the butter, which is going to be um, the limiting reagent, and which one is going to be the reactant in excess. That is, which one is going to finish first and which one is going to remain. So that's the concept behind limiting reagent and reactant in excess in chemical, reactions. So now let's look at it. Now, to make one sandwich, we say we take what? 2 slices of bread. Let's take 2 slices here. Then we take 3 slices of butter. So we've made one sandwich. So let's say this is one sandwich. One sandwich. But we still have what? Some slice of bread and some slice of butter. So we are not done. Let's try and see if we can make another sandwich again. We take 2 slices here, then we take 3 slices of butter again. So this is another what? Another sandwich. Right? So now you see, we are left with what? 2 slices of what? Bread and 2 slices of what? Butter. But they said for us to make one sandwich, we need what? 3 slices of butter and 2 slices of bread. So 2 slices of bread, it can make a sandwich, but 2 slices of butter can't. If it was three, then we would have made another what? Set of one sandwich. So which one of these reactants runs out first? Now if you watch keenly, you see that butter what? Runs out. So the butter, the bread, and the butter, which one is the limiting reagent and which one is what? The reactant in excess. So looking at it keenly, we know that we do not have any sufficient butter or slices of butter that we can combine with what? These 2 slices of bread to make one sandwich. So butter is what? Completely consumed during the what? The chemical reaction. So we can say the butter here is the limiting reagent. The limiting reagent, and the bread here is what? The reactant in excess. The reactant in excess is the reactant in excess. So, hope you understand this illustration. So now let's go to the definitions. Um, Remember I told you that limiting reagent is the reactant that is completely used up in the chemical reaction. So we can define it as the limiting reagent, we say, is the reactant that is completely used up, completely used up in a chemical reaction. It's completely used up in a chemical reaction. We say it determines or it limits the amount of product formed. Since it is going to run out first, so it limits the amount of product, the amount of product that is formed in a chemical reaction, right? It is going to limit the amount of product that is formed in a chemical reaction. So once this limiting reagent is is completely used up, the reaction is going to stop, right? Once it is exhausted, the reaction is going to stop. Even if the other reactant is what still available in excess, the reaction is completely coming to an end. So we can now say the excess reactant or the reactant in excess is the reactant that is not completely used up in a chemical reaction, right? The reactant in excess, reactant in excess is the reactant that remains or that is not completely used up in a chemical reaction. It is not completely what exhausted in a chemical reaction. So this one is what the reactant in excess. So you remember the illustration I gave? It was, for us to get a better understanding of the concept. So now I want us to look at a chemical reaction, wherein we'll be asked to determine the limiting reagent and the reactant in excess and the amount of product that is what formed. So let's look at this reaction. Example, let's say we are given 2H2 plus O2 that gives us 2H2O. So now let's look if this equation is balanced. Here we have what? 4 hydrogen, 4 here, 2 and 2. So it's a balanced chemical equation. So now this is a chemical equation. Now let's say we are given 8 moles, 8 moles of H2 and 6 moles of O2. Now the question says, what is limiting the limiting reagent and What is the reactant in excess? The reactant in excess. Then, what is the mole of product form? The amount of product form. The amount of product form. So let me just shorten it that way. So we want to solve this question. But in some textbooks, they will not give you exactly in moles, they will give you in gram. That is the mass. So you are going to, play with some physical quantities or some formulas in stoichiometry. Then you now convert it to mole before you can what? You can solve it. But this one is a direct you know, question that needs a direct approach. So this is the question. They said we are given 8 moles of H2 and 6 moles of O2. Now they said we are to determine the limiting reagent and the reactant in excess and the amount of product that is formed in this chemical reaction. So what I want to do, I want us to, I want to delve into a mathematical approach in solving this question. So that is, I think it's somehow simple. So the coefficient of H2 here, or let me just say we rewrite the chemical equation again. This is 2H2 plus O2. It gives us 2H2O. So the coefficient of H2 is 2. The coefficient of O2 is 1. And the coefficient of H2O here is what? Is 2. So if we want to determine the the limiting reagent, let's start with hydrogen. For hydrogen, right? Or for H2, right? Let me just say for H2. For H2, we say the coefficient here is 2. So let's divide the number of moles of H2 by this coefficient. So you can say 8 divided by 2, it gives you what? 4. Huh? It gives you 4. Then you come to what? For O2, the coefficient here is 1. So you divide the number of moles. 6 by 1 is the same as what? 6, right? So the after we divide the number of moles of H2 by the coefficient, it gives us 4. And the number of moles of O2, we divide it by the coefficient of O2, which is 1, it gives us what? 6. So 4 and 6, which one is greater or which one is less than? So you will notice that what? 4 is less than also. So that tells you that H2 is going to what? Is going to finish or is going to be exhausted early. So we can now say H2 is the limiting reagent. So limiting reagent. Let me just put it like this. So the limiting reagent is going to be what? H2, because after we divide the number of moles by the coefficient, it gives us what? A lesser number of mole, which is 4. So the reactant in excess is going to be what? O2. So now if we want to determine the amount of product formed, you now look at the the lesser, the limiting reagent. The value that the limiting reagent gives us here is what? We say it's 4. Then you multiply it by the product coefficient. Why are we doing that? Because we know that the limiting reagent is going to determine the amount of product that is formed in a chemical reaction, as I said earlier. So if that is the case, this 4, you multiply it by the product coefficient, which is 2. So 4 times 2 will give you what? 8 moles. So can I write this one in moles? This is in moles. So therefore, 8 moles of what? Water is going to be formed in the chemical reaction. So to answer the third part, we can say 8 moles. 8 moles of the product is going to be formed. So this is just how we handle such questions. So in case you have any question of this nature, right, you can use this mathematical approach to solve. I think it's somehow simple. So thanks for watching, and make sure you like this video, you share with your friends and classmates, then also turn on the notifications so you never miss a lesson. Thanks for watching.